Okay, let's talk about some parts of solids so we'll know what we're talking about. We're going to talk about cross sections of solid, but parts of solids we need to talk about. First of all, let's talk about bases. We're going to use several different figures. We're going to identify what the base is. This right here is known as a pyramid. It's known as a square pyramid from its base. Pyramids are named from its base. It has a square bottom or base, therefore it's known as a square pyramid. Now pyramids, its lateral sides, okay, its sides will be triangles. Okay, so this is a square pyramid. It will have as many triangles as we have sides on the base. How many sides does a square pyramid have? 4, because there's 4 sides on the base. Therefore, it will have 4 triangles. Now, let's talk about a right solid and an oblique solid. This is a right solid. Why? Because the vertex, a line directly through the vertex to the base, is perpendicular to the base. So if we were to draw that right solid looks like this, and it's directly perpendicular to that, and this is the center of base. Okay? And this height is perpendicular to it. Okay? That's perpendicular to it. When that is, we call it a right solid. Now let's talk a little bit about oblique solid. An oblique solid would be a pyramid that looks like this. Okay? The center of the base is right there. Well, if we were to attach the vertex to the center of the base, that's not perpendicular to it, is it? Okay? This is perpendicular to it. So anytime the center of the base is not perpendicular, okay, to the base, whenever we connect the vertex of the pyramid to the base, then that's called an oblique. Okay? Let's look at something else. This is called, how many sides does it have? Does the base have? The base, this one is a prism because it has 2 bases that are exactly the same. By the way, the bases are the two sides that will be identical. What 2 sides are identical? Well, I got 1, 2, 3, 4, 5, 6 sides that are identical. I need 2 sides that are identical. 2 sides that are identical are the hexagons. Therefore, this is a hexagonal prism. 2 sides that are the same. Now, is this a right hexagonal prism or an oblique? Well, if we connect the center of the bases, is that line perpendicular to those bases? Yes, it is. So this would be a right prism, hexagonal prism. Let's look at this one. This is a cylinder, and again, if we were to connect the center of the bases, those circles, are they perpendicular to those bases or those circles? Yes, they are. So this is a right cylinder. Now, an oblique cylinder would look a little bit like this. It would look like this, and then it would come down like this, and it would look like this. So this would not be perpendicular. The perpendicular is over here. This would be the height. Okay? Just like parallelograms, we have to find the height, and when we do that later in 12.2, we'll talk about that. But this would be an oblique. Oblique meaning not perpendicular, oblique cylinder. Okay? So those concepts of the base, let's talk about some more. Here's another one. What 2 sides are the same? Well, I have 3 sides that look like squares, but that's 3 sides. I need 2 sides that look the same. Oh, I have 2 triangles. So this would be a triangular prism, okay, because it has 2 bases. Okay, what's this? Round, base is a circle, comes to a vertex. This would be called a not a pyramid, but a cone, okay? So this would be a circular cone. They could have elliptical cones. All right, now let's look at this one. 2 sides that are the same. Well, let me see. These 2 sides are the same, and these 2 sides are the same, so that's 4 sides the same. So let's just get 2 sides the same. Oh, okay, those 2 sides are the same, so this would be a square prism, okay? If I call this a square prism, you would know that these squares are the bases. Is this a right square prism or is it oblique? If I connect the center of the bases, is that line, that height, is it perpendicular to the bases or is it slanted? It's perpendicular, therefore this would be a right square prism. Cube. Call it a square prism, we call it a cube. Why? Because all of its sides are the same. Okay, is it a right cube? Well, a cube means that all the sides are perpendicular to each other. So this automatically is a right. Okay? So what we're going to do is we're going to talk about these parts of solid. Let's talk about if we were to cut these. Okay, first of all, let's talk about a pyramid. If we were to cut a square pyramid, we were to take this and make slices parallel to the base. So first of all, we're going to talk about sections, cross sections, parallel to base. Okay? If we make a cross section parallel to the base, what are we going to get? Whoops. We got to get exactly what that base is. Well, what is that base? It's a square. Is it going to be the same size? No. Why? It's going to get smaller. Well, let me see. This prism base is a triangle, so if I cut parallel to the base, what am I going to get? On this one, I'm going to get triangles that are the same size. It's just like slicing a loaf of bread. Parallel to the end of that loaf, I'm going to get very similar pieces. What happens if I slice parallel to this base on this cone? I ought to get what? I ought to get circles. What happens when I slice parallel to the base on this hexagonal prism? I ought to get hexagons, shouldn't I? The same kind. So when we slice or we take a cross section parallel to the base, we're going to get a figure or a two-dimensional figure that looks like that base. Cylinder, slice it like this. This reminds me of, it's red, it's not deep enough red. Reminds me of Thanksgiving here in the United States where we have congealed cranberry sauce that is pink in here. We slice it up into slices and we put it on our turkey and dressing and so forth and so on as we celebrate Thanksgiving. It reminds me of my mama doing that, my mother doing that at Thanksgiving. I would help her and we would have circles. Okay? Alright, so parallel to the base, we're going to get what the base looks like. Now, let's talk about perpendicular to base. What's going to happen when we take a cross section perpendicular to base? Well, let me see. Let's look at a cylinder. If we cut this perpendicular to the base, look at that just the way it is, without the circle. What do you got? I got a height and I got a length, don't I? So if I cut this perpendicular, what am I going to get? I'm going to get a rectangle, aren't I? And as I move this away, these rectangles are going to get smaller and smaller and smaller until finally all I get is a line. Okay? So think about that. As I cut this way, perpendicular to the base, this way up and down, I'm going to get rectangles. Think about this thing. I want to cut it from here to here. What's going to happen? Through the vertex. As I cut this thing perpendicular to the base, through the vertex, what am I going to get? I'm going to get a triangle, aren't I? What happens as I cut perpendicular on over here? Oh, let me see. I'm going to get something wide at the bottom, narrow at the top with four sides. Wide at the bottom, narrow at the top with four sides. Looks like that. What do we call that? Trapezoid. But when I get here, we'll have another triangle. What am I going to get here if I cut perpendicular to the base through the vertex? I ought to get a what? What's this shape? Has 3 sides? It'd be a triangle. What happens here when I cut perpendicular to the base? Get a rectangle, aren't I? Going to get a rectangle. Okay, what's going to happen here when I cut parallel to the base? Now I'm going to cut perpendicular to the base. Well, I'm going to get something that looks like this side, or I'm going to get a rectangle. Okay, so when we cut perpendicular, we're going to get a profile of the faces. What are we going to get? We're going to get a profile of this face. We're going to get a triangle, or we're going to get something that has sides. We're going to get a profile of this face. If I cut perpendicular, if I cut this one perpendicular, what's that going to look like? Take a cross section. It's going to look like a rectangle, isn't it? Okay? So that's one of the things we need to look at. Now, let's talk about one more, and that is oblique to base. Oblique means at a slant. This means at a slant. Okay? So we're going to come at it just at a slant. Alright, let's look at this. Let's see what we get. What happens when we come in here and we go slant this thing? We're going to get a 6-sided figure, but it's not going to be an equilateral hexagon, are we? What happens to this thing if we come in at a slant? Think about it. We're going to get an ellipse, aren't we? Okay? Let's look at this thing. Oblique to the base, I come in at a slant, I cut it here and I cut it here. What's our cross section going to look like? Well, that's just that trapezoid we get if we come on and cut it perpendicular to the base off the vertex, right? We're going to get that trapezoid. Okay? What if I come in here, oblique to the base, across here? Going to get an ellipse, aren't I? Get a strange looking ellipse. Okay? Understand? A square prism. Here's my square prism. Okay? What if I cut oblique to the base? Let's take this thing. What if I cut this way? Oblique. What if I cut from a diagonal to diagonal? In other words, sideways. This is a cube. All the sides are equal. Same area, but all of a sudden I'm going to create something that looks like this. Well, this side's going to be longer, isn't it, than this side? And this side's going to be longer. And when I look at it, and I look at it like that, wow. You understand? From here to here is taller than it is wide. If I have something that's taller than it is wide, all the angles are 90 degrees, I have a rectangle. So your ability to look at cross sections and know what they look like and see what they look like is extremely important. It takes practice. Okay? I urge you, get some of these, have fun with them. If you can find some old ones, cut them up. Make some out of Play-Doh or whatever else, clay, cut them up. See what happens. Okay? Make some cookie dough. Okay? At least that way they'll be edible, you know. Take some out, make you some cookie dough that looks like this, chop them up one way or the other, see what happens, and then you can eat the results. And that would be a whole lot more fun than what I'm doing tonight here. Okay, so this is chapter 12:1. A lot of things to do, a lot of things to think about. And I urge you to challenge your friends. Pick one of these things up, look at it, and say, what do I have if I cut it parallel to the base? What do I have if I cut it perpendicular to the base? What happens if it's oblique to the base?